Dear students, in this presentation, we'll solve one problem on KMP. KMP stands for Knuth, Pratt, and Morris. These are the three great mathematicians who developed this algorithm mainly for pattern matching. Pattern is a part of the string which you are going to look in the main string. You will be given a string, you have to find out a particular string. For example, in this case, KMP algorithm is used to find pattern in a string. I wanted to know whether find is there or not. Find is my pattern and this KMP algorithm is used to find pattern in a string is the main string. Okay. The purpose is that in my word processing, I may have to replace it. For that I have to find. I have to find it first. Then I have to replace. To find or for replacing, we need a part of the string that is called pattern. This is one example with reference to the string. So to do that, we need one special table. The table is called longest proper prefix table, LPS table. It's also called proper prefix table. We'll see that how that can be obtained. Let us take simple example. AAA is my pattern. Now I have to find out the prefix strings, proper prefix string and suffix string. The prefix string starts with null character, ends with the last character one by one. I'll be starting from one character, two character, three like that till the last these many number of characters. Okay, now we'll take the first character A. A is my only one character that is there. So you have to include even null also, null and A. For A, null one combination. Second combination I'm going to take just one A. Next all for this one. Null, one A, two A's and three A's. For this one. Null A, 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 AAB, AAB. The last one. I will take this one. A, for say null, A, AA, AAA, AAAB, AAABA, AAABA, AAABAA, AAABAA. Okay, so that is the prefix string. We are going to find out or get all the combinations starts with the null also. Null is also a prefix. Then proper prefix. It is similar to the prefix only, but you should not include the original string. In this case, original string is A that you should not include. Rest of the things you have to write it. Like in this case, the original string is AABA that you should not include. All other things you have to include here. That is the proper prefix. Proper prefix is the set of strings where original string is not included. It is same as set of prefix. Next, suffix. The reverse of prefix is the suffix. Okay. Anyway, only one character, null and that character. In this case, two character. So thing is that you have to start from here, but while writing string, you have to write as usual. You have to start from the end. That means null A, then AA. Null A. Okay, we'll take. So this will be more proper one. First is null. Anyway, I have to include that null. The last character B, then AB, then AAB, then AAAB. Hope you noticed. Here in this case, suffix now to start from right side. In case of prefix, I have to start from the left side. But don't change the order of the string. String should not be reversed. Only the direction, that side A left side or the right side. Okay, one more example I can take. This one. Null A, B A, B A, B A, B A. Then the LPS string. LPS string is the longest match, longest proper prefix, uh, longest match. Now you have to compare this proper prefix and suffix column. In that, the common one. In that common, find the longest one. Null and null is the common. Length of that is 0. Null and A are the common. A is the highest one, longest one, so its length is 1. Null and A are common. A is the longest string which is appeared in both columns, so its length is 2. We'll take this example. Null appears here, A is there, A is there, A is there, and rest of the things are not there. That is why this is the longest one, so its length is 3. 3. So this is the LPS of this one. This is the manual method. Okay, this you can do only for the smallest string, but for bigger string what to do? For that we need the algorithm. The algorithm goes like this. First we need one dimension array which is initialized with the size of the pattern, and we are going to compare characters. For that, two indexes required. Let I be one index, j is the second index. I starts with 0 because we are going to start from the first character. It's of no use to compare the first character with the character only, so we have to start from the second character. So j equal to 1, and the first one LPS in that array, the first entry always 0. This is the initial setup required. You repeat till you reach the end. So two characters you have to compare. The first character, second character, first character, third character, like that. You have to compare. If they are same, we'll see with the example. If both are same, then you have to enter in that array I value, that incremented value of I. If I value is 0, 1 you have to enter. If I value is 2, 2, 3 you have to enter, like that. Then you have to increment I and j. Again you have to repeat it. Suppose these two patterns are not same. Again, you have to check whether I value is 0 or not. If I value is 0, in that place, in that location of LPS, no, you put 0. Increment j. If I is not same, then the new value of I value is LPS of I minus 1. LPS of I minus 1. This is the logic. Okay. Now we'll solve one problem. Let us take this as the pattern. A, B, C, D, A, B, D is a pattern. The size of this pattern 7 characters. So I have to initialize now array, one dimension array of size 7 because I'm going to put the length. Right now LPS value is 0. As per the algorithm we have to put 0 here. Now the first character and the second character you have to compare. Are they same? A and B are not same. A and B are not same. Now you have to check value of I. I value is still 0. So in this place you have to enter 0 and you have to increment the value of j. Now j becomes 2. Earlier it was 1, now it is 2. This is the status of the LPS after comparing the first and second character. Repeat it. Still I value is not changed. I at 0 only, but j is now 2. Compare 0th character and second. A and C are compared. A and C are not same. I value is 0 only. So LPS value will be 0. This value to put 0. Increment the value of j. Increment the value of j. This is the status of LPS array after comparing first three characters. I value array same place, j now 4. Okay. J value is the fourth character. The location is 3, the fourth character to compare. That means A and D are compared. A and D are compared, A and D are not same, I value is 0, so in that place you have to put 0. In this place you have to put 0. Now we have compared first 4 characters, J value is now incremented by 1, J becomes now 4. So 0th character and 4th character you have to compare, A and A same. If same, what to do? You have to increase the value, that I value you have to put. LPS of 4 is I value plus 1. I value was 0, now it becomes 1. So you have to put 1 here. So this is the status of LPS array. Now this is 1. This is 1. Now I and J have to increment. J becomes 5. Earlier it was 1, now it is 0, now it is 1. That means first and fifth character have to compare. First and fifth character to compare. B and B same. If same, the LPS entry you have to increment, you have to update by the value of I, like this. I value was 1, now it is 2. This is entered. Okay. The last one. Now J value is 6, I value is 2. Second and sixth character to compare. Second and sixth character to compare. Second and sixth character to compare. They are not same. Check the value of I. I is not 0. So you have to increase that LPS in that location. It is 2 minus 1. I minus 1. LPS of the new that I value is LPS of I minus 1. LPS of I value is 2. 2 minus 1 is 1. LPS of 1 is 0. LPS of 1 is 0. That is the value of I. Anyway, we have completed all the things. In this location, you have to put 0. Here you have to put 0. So this is the first step of pattern matching algorithm, finding LPS. This is the LPS array. This is required to solve the next part. In the second part, this is a pattern matching algorithm. Compare two strings. One is the main string, other one is the pattern string. One by one character at a time. Whenever you compare and mismatch is found, what to do? Check the LPS value. That is why LPS value is very important. You can get that LPS value either manually or with the algorithm. For smaller string, manual method is okay. For big number of characters, patterns having too number of characters, manual method will not work. So you have to go for automated, that algorithm part. So when a mismatch occurs, check the LPS value, that is LPS of I minus 1. I minus 1 indicates where the mismatch found its previous character. If mismatch found at third, then second is the index. 3 minus 1 is 2, like that. I minus 1. The character just behind that mismatch. If LPS of I minus 1 value is 0, start comparing from the very next to the mismatch place. Next to the mismatch place. If mismatch found at 3, you have to start from 4. Like, suppose a mismatch occurred here, then you have to start comparing from the next place. That's the meaning. If LPS of I minus 1 0, if not 0, that many number of characters behind it where the mismatch found, behind that you have to start. And you will come to know while tracing the algorithm. This is my given pattern. Say ABC. The pattern you write it in a box form. Pattern and the main string. This is the main string and this is a pattern. A matched, go to the next character. B matched, go to the next. C and C matched. Here mismatch found. The index of that is 3. Not the index of the character, index of the pattern. It is 3. Mismatch occurred at index 3. So you have to check the LPS value. LPS of 3 minus 1. LPS of 2. LPS of 2 is 0. That is required for pattern matching. That 0 indicates that you start from the next character. So which is the next character? This here the mismatch found, go from the start from the next character. Again you write pattern as well as the original string. A matched, B matched, C matched, D matched, A matched, B matched, mismatched. At 6. At 6 these two characters are not matching. So LPS of 6 minus 1. LPS of 6 minus 1 is LPS of 5. That is LPS of 5. That is 2. So two characters behind where the mismatch found. Here the mismatch found. From here you have to start. That is the meaning. Here the mismatch found two characters behind. A, B, C, D like that. So again mismatch found at index 2. 2 minus 1 is 0. Sorry, 2 minus 1 is 1. LPS of 1. LPS of 1 is 0. LPS of 1 is 0. That means you start from the next character. Here the mismatch found, you start comparing from here. That is the meaning here. This is my pattern, this is my remaining part. A matched, B matched, C matched, D matched, A matched, B matched, and D matched. No more characters found. So here this is the last index what we have reached, 17 minus 6. What is this? 17. 17, where the string started. 11th character onwards, all the characters of the main string and the pattern are matched. So found at 11. This is the place where all the characters are successfully compared and found same. So 11 is the pattern index where matched. You can try other example. ABC, one space, ABCD, AB, one space, ABCD, ABCD, ABDE. You can try that. So if you try that, you get somewhere 17 something will get. Anyway, you try that. That's all about pattern matching algorithm. Thank you.